Hello, this is Edward here for ChargeCore Studio, and today I'm going to continue the VB.NET series. I'm going to be showing you sort of how to make your project sort of redistributable for others, some general sort of coding tips, including use of if statements, and explaining the differences and sort of stuff to do with functions and subs, and sort of starting to introduce you to some object-oriented programming concepts. We use these more when we go to Windows Forms than will be necessary in Comp 1, so sort of try and stay away from that in Comp 1. We don't want sort of multiple classes in Comp 1 really, unless don't get me wrong, if they explicitly say use another class file, which then obviously do this, but if they don't, then don't. The first thing I'm just going to sort of show you is sort of how to build your project to a release, because they've shown you sort of the old trick of copying and pasting out of the bin debug folder the exe, and that works to a certain extent, but when you start to get sort of larger programs, you end up with this there's a thing that's sort of built into that exe that you're used to using, or that exe that I just showed you, which is called like debugging, and that's basically what allows you to interface, or allows the program to interface between Visual Studio and the sort of thing. So when you run here and you get a crash, it's essentially starting the exe and it's sort of linking the two, and that can add a lot of weight to your not a lot, but it can add a bit of weight to your program that is sort of unnecessary when you're sort of distributing your actual program. So I'm just going to sort of show you how to take that sort of side of things out of it. In order to build your product, it's fairly simple. You do a debug and then click build, and then whatever your project name is, so build methods. So now what this does is inside my bin and release folder I now have an exe and a couple of other files. You distribute these to your people when you're using it. I might do a tutorial when we start to get to Windows Forms and how to make installers for your applications, so those that sort of need, because I mean programs like this don't have any sort of dependencies on any folders or libraries, class libraries, so like .dlls, but for some of the stuff that some people might choose to do for their projects, you might need to sort of set up an environment, so you'll need to know how to create setup programs to run. So I'll show you more of that over the summer when it becomes more relevant, but obviously that was just a quick thing just to show you how to take out the debugging side. So this is the application that we're actually going to be building today. So enter first number is sort of like an extension of the calculator that I showed you in episode 1. So enter second number, enter operation, plus, and you get 3. It doesn't seem particularly special on the outset, and there's sort of not a lot different about it at first glance. You think, oh, I know how to write that already if you've been doing VB.NET sort of things. But this is something which they haven't shown us in college per se, which is multiple class usage. This is not the only use of multiple classes, though, just to sort of make things a bit more organized. So I've sort of got like what I'd call a calculator client, I suppose, which manages the getting of the first number, manages user inputs, and then I've got this sort of thing which I called calculator core as a math API, and this is just a handwritten class which I made. So obviously if we were to extend the calculator further by adding like trigonometric functions and base conversions and stuff, we'd put our sort of more calculator mathsy stuff in here. Obviously this is a separate class and it only has one method. So I hear you sort of ask, what is a method? Well, in order to sort of determine that, I've sort of made these other graphics again. It's just some sort of basic definitions, just so that you know what I'm talking about, really. So subroutine, or sub, as is abbreviated in VB.NET syntax, a sequence of program instructions that perform a specific task packaged as a single unit, also known as a callable unit, because you can call them. In VB.NET, they do not directly return a value, and so cannot be used in assignment statements. So you can't say, for instance, an integer variable, call it number, equals, and then a sub, because that sub doesn't necessarily return any value, and you can't use a return statement in it. That's sort of where we run into functions. Functions do return things, and they can be used in assignment statements. So just to read what I've written: a sequence of program instructions that returns a value to the caller, also packaged as a single unit, and you could call them callable units. In VB.NET, they are like subs, but they return a value, and so can be used in assignment expressions. And my final sort of definition is method, and this is sort of taken from Wikipedia. In object-oriented programming, which I'll talk more about in other future episodes, a method is a subroutine which is associated with an object which has access to its member variables. In VB.NET, they're either subs or functions. So subroutine here is subroutine under Wikipedia's definition, which encompasses functions as well. So when I say subroutine here, that's what I mean. And then sort of more specifically in VB.NET, they're either subs or functions. So they are either the VB sub or a standard function. When you sort of go on to do sort of a more advanced programming language like say C# or Java, this idea becomes more obvious, because you declare them using the same sort of the same keywords you used. It's just if you're writing something that's not going to return a value, you use a keyword called void. Obviously, I'm contemplating doing some C# tutorials over the summer. It depends how I get on with VB.NET, and sort of if I discover any limitations, I might say, well, this is how you can do it using C#, which is installed on the college computers. So yeah, that was just sort of a sort of tangent, sort of themed with today's things, which is subs and functions. So I'm going to just create a new project called calculator. Calculator subs. Right, so I'm just going to be coding sort of that application that I showed you earlier. So we'll start with our input functions. Now obviously the sub main is always got to be called the main, because that's the sort of like the entry point for your application. And when you go onto Windows Forms, your sub main is sort of hidden in a different thing, because that's sort of what initializes all of the bits that make up your Windows form. So you don't sort of see that as of it. You usually just load a use the onload event. I'll talk more about events when that becomes more useful. So we need to write a couple of functions. So to write a function in VB.NET, you start with the function keyword, then you give your name a function. Sometimes they'll start with get or set, especially when they're inside classes. That will become more obvious with time, obviously. So get user input 1, and then hold on, I'm shouting. Okay, so get user input 1. So when this function is called, obviously at the moment I've got this thing because it doesn't return a value at all. So console.writeLine. There are a couple of functions like these in the actual skeleton program as well, those of you that have access to it. So enter first number, and then close that up, and then there are two ways of sort of setting what gets returned on a function. You can use the function name and then equals and then console.readline, obviously, because console.readline will just put the value in. There's no point in saving in a variable every time, save on memory space. I'll talk more about this in validation and stuff as well if we come back to this program. So, and then function get user input to console.writeLine, enter second number, and then get user input to equals console.readLine. And finally, we need to get our operation. So function get operation console.writeLine select operation, and then we'll put in the possible things. So we can have plus, comma, plus, minus, divide, or multiply, and then get operation equals console.readLine. Okay, so that's sort of like our client functions. Now, to create a new class, I believe I said this before, add class, and then so it's here, and then if we just call this math core, and then obviously we'll need a single sub in here. So to declare a sub, if you hadn't gathered already, it's sub keyword, and then you get sort of like this thing, and you close all subs with the end sub statement. So sub, and then we'll call this get answer, and then sort of this is another sort of way of selecting things. You could use nested if statements for this, or else if, sorry, and but I'm going to use a thing called select case since we're only dealing with one input variable. Select case, and then I need to up here. I'll talk more about parameters in a future episode. Just for now, if you're sort of just looking at this, we're passing by val, sorry, num1, comma, by val. I'll talk more about what this means in a future episode, I do promise. Num2, comma, by val, operation code, and then as char needs to be as integer, and this needs to be as integer also. So select case, and then case, and then select case, and then operation code. This isn't necessarily the most efficient way of coding it, though it's just one that's sort of easier to do at the moment. So case, the operation code is an add sign. Where are we? Sorry. Just turn the light on a bit. Case plus return. This is the other way of returning a value on a function. Sorry. Yeah, there should be a function. Right, okay. Function. Return num1. As you can see, our variables now appear in here because our parameters now appear in there. Num1 plus num2. Case. Remember it's a minus. Return num1 minus num2. case, so multiply, return num1 times num2, case, divide, return num1 divided by num2. So obviously with this sort of return versus setting it equals to, in more advanced languages like Java and C#, I don't know why I keep quoting them, also probably C++, you sort of lose the ability to do this equals thing. So if you're thinking of moving on and continuing with programming, I recommend getting into the habit of just using the return, just to make things easier when you do make the sort of transition. And then obviously this says not all code paths, because it thinks if the operation code's none of that, then it's going to do it, in which case we just want to return a big fat 0. So that doesn't influence the calculation anyway. Right. Okay. So sort of how do we sort of link these two classes? Well, if you were sort of trying to do something as like, almost like you're trying to code the animal kingdom, let's say, you'd probably use this thing called inheritance. But since we don't, since sort of like our calculator is not going to be a combination of these two sort of directly, we don't use inheritance. Instead, what we do is we create an instance of this class in this other class. So in order to do that, we do dim and then call it math core as, and then this is saying the type, which is math core, equals new math core. So sort of why do we have to say it twice? Well, the first time we say it, we're declaring the type for this variable, and the second time we do it, we're initializing the variable. So yeah, so that's sort of what actually gets it running. That's just sort of for use in other areas of code, so it knows what to give us access to. One thing we need to do is make this thing public, so that we can access it from outside this class itself. So then what we do is we say mathcore dot get answer, no, not dot equals, there's a few sort of like built-in methods that you have for every class, so you don't need that. Mathcore dot get answer, num1 as integer, so that's going to be get. So obviously if these were subs, they wouldn't work as assignments. Num2 as integer, get, oh, sorry, not assignments. And then get operation. And then obviously to keep our window open, we need console.readline. And we need to put this whole thing in a console.writeLine, and then we're going to write out that. And I think we need to put parentheses on these just so that it knows it's a function, not a variable name. So it actually runs it. Okay, so we've built that all up. Calculator subs, save. If we just run it from inside here rather than putting exe, enter the first number. 3, enter the second number, 4, select operation, we'll do a simple add, and it's 7. Okay, and obviously using what we know from